So here's a couple of short examples, and maybe a little more graphic than we've been doing so far. Here's a sloped-intercept problem. It says here's a line that has slope m equal to 3 and y-intercept 0, 7. Let's find the equation and let's sketch the graph. So we know the form of the equation is y equals mx plus b. So we just write it down. Y equals 3x. B is the y-coordinate of the intercept. Did that. And then we'll sketch the graph. Make some axes. I'm kind of concerned because the intercept is 7. So I have to be careful how I set up my vertical axis. I can't make that 1. I'm going to have to use different scales on the two axes. That's not a problem. I guess I'll just go like this. And I'm going to plot the y-intercept, 0, 7. That's why I had to make that a 10. Maybe here. And now it's a little bit harder to get the slope right. I want to get slope 3. So I want to go over 1, which is this far, and up 3. So 7 is 3 units away from 10, so I want to be up at 10 here. Now if I go over 2, I'd want to go up 6. I would be at 13. So there's what slope 3 looks like when the two scales aren't the same on the two axes. And sometimes you just have to do that. There we are. Not knowing the scales on the axis, you might think that slope is a little bit less than 1. But actually, the slope is 3. And then we'll come over here, point slope example. So here's an equation that you might face. And if you recognize it, it looks like it's in point slope form because that's y minus y1 is m, x minus x1, like that. And so we can read off the point on the line. The x is 5. Is 5 minus x1. I got to write that x minus 5 to make it work. So the x is minus 5. And the y is 3. You don't have to do any fancy stuff for that. And we can read the slope at minus 2. Now we can try to sketch that. I have to make sure I can get minus 5, 3 in the game. Maybe I'll make a little tiny scale here. 1, 2, 3, 4, 5, 6, 7, 8. I guess that's good enough. And now I want to put minus 5, 3. So what are we doing here? So we've got an equation. We identified it that it was in point slope form. And so it allowed us just to read off the point and slope. And the second thing we want to try to do then is to try to sketch the graph. So here we are sketching the graph. Minus 5, 3 is here. And now I want to put a line in there, a slope minus 2. So that would be over 1 down to, we're at height 3 right now. Over 1 down 2 would put us there. And over 1 down 2 again would put us here. So slope, I can't do it. Here we go. Slope minus 2 like that. Well, I wonder, where does this line eventually come up here at hit the axis? We can find that out by writing the equation in slope-intercept form. Is it minus 6, or is it further down? We'll just take this equation and solve it. Put it here. Y minus 3 is minus 2x minus 10. Minus 2 times 5 is minus 10, okay. Then add 3 to both sides. Minus 10 plus 3 is minus 7. So the y-intercept down here, minus 6, minus 7, kind of matches our graph. Was a good guess. Better make this 7 prettier. There we go. So there's two examples. One about slope and intercept and writing the equation, sketching the graph. The other one about recognizing an equation that is in point-slope form, and then identifying the point and the slope from the values in the equation, and then quickly sketching that. Ordinarily, we're going to be sketching lines either by knowing the intercept and knowing the slope, or just knowing any old point and knowing the slope. Sometimes the intercept's not really convenient to use, especially if you already have a point given and you already have the slope and just want to sketch it. So those are our two examples. Let's move on. I think we have horizontal and vertical lines to worry about next, but I might be wrong.